Hello everyone. In this session of CCNA series, I'll be discussing about spine and leaf network architecture. Many things have changed in the data center over the last decades or so. In fact, so much has changed that the old three-layer model of access, aggregation, and core is no longer ideal, as this model was designed based on a south to north flow of data. Currently, a new architecture is replacing the traditional three-tiered network architecture, which is also known as spine leaf architecture. The spine leaf architecture was developed to overcome the limitations of three-tier architecture. Given the prevalence of cloud and containerized infrastructure in modern data center, with east-west traffic continues to increase, spine leaf model is the ideal choice for building the modern data center network. Spine leaf is a two-layer network architecture composed of leaf switches and spine switches. The leaf layer consists of access switches that connects to devices such as servers, storage devices, and WAN or internet devices. Those switches are also called as TOR or top of the rack switches or EOR end of the rack switches in modern data centers. The spine layer is the backbone of the network and is responsible for interconnecting all leaf switches. In this two-tier silos architecture, every leaf switch is connected to each of the spine switches in a full mesh topology. Leaf spine network is more useful for data center that experience more east to west network traffic than north to south traffic. Let's look at some of the advantages or the characteristic of the leaf spine architecture. While in a three-tier network, one server may need to traverse a hierarchical path through two aggregation switches and one core switch to communicate with another switch, which adds latency and creates traffic bottlenecks. With a spine and leaf architecture, no matter which leaf switch a server is connected to, it has to cross the same number of devices every time it connects to another server. The only exception is when the other server is on the same leaf. This approach keeps the latency at a predictable level and minimizes bottlenecks. Because a payload only has to hop a spine switch and another leaf switch to reach its destination. Each leaf connects to all spines with no interconnections among neither spines themselves nor leaves, which creates a large non-blocking fabric. Another important advantage is the scalability. If oversubscription of a link occurs, the process of expanding capacity is straightforward. An additional spine switch can be added, and uplinks can be extended to every leaf switch, resulting in the addition of interlayer bandwidth and reduction of oversubscription. If the device port capacity becomes a concern, a new leaf switch can be added by connecting it to every spine switch and adding the network configuration to that switch. The ease of expansion optimizes the IT department process of scaling the network. If one of the top tier switches were to fail, it would only slightly degrade the performance throughout the data center.